We are Hudson Space Systems, and we offer microgravity as a service. Before we get into business, let's first explore why microgravity is so important for science. Gravity is one of the fundamental interactions of physics. Simply put, it's an omnipresent force that influences everything here on Earth, from the way we walk to the way two liquids mix. It's a common misconception that there is no gravity in space. In reality, the force of gravity is present anywhere there is matter. The more matter, and the closer it is, the more gravity you experience. Because astronauts aboard the ISS are relatively close to Earth, they actually feel about 90% of the effects of gravity that you and I experience right here. But how are astronauts floating in space if they still have roughly the same gravity pulling on them that we do? The answer is that the space station is falling towards the Earth. But don't worry, it was designed to do that. Earth's gravity, in combination with the tangential momentum of the ISS, makes sure that the space station stays in an orbit around the planet. And everything inside the space station is also falling at that same constant speed. That's why objects aboard the ISS appear to float. They're all free-falling toward the Earth at the same speed as the ISS. We call this effect microgravity, since objects appear weightless. Because their free fall is endless, those objects don't have to oppose the force of gravity as they do here on the surface. Scientists can use microgravity to accelerate their research. Take a standard chemical reaction, for example. On Earth, we're limited to what we can observe on a surface, or top-down in a container. In microgravity, we can observe the reaction from any angle, without any surface contact. Beyond just being able to observe a reaction better, microgravity enables different scientific outcomes that would be normally impossible on Earth. Researchers at NASA were able to manufacture insulin crystals, which exhibit unparalleled size and optical clarity. As a result, researchers had more information about the crystal structure, which helped them develop better insulin therapies. That's just the tip of the iceberg. Microgravity has been used for researching pharmaceutical R&D, organ growth, microchip fabrication, and more. So you might be thinking, I have some research I need to accelerate. Let's get ourselves a rocket and test this out. But it's not so easy right now. Take Linda, who is a researcher in academia. Linda's been working on research that could benefit from a microgravity experiment. She's first going to have to find funding to make the launch happen, which can be very costly. Assuming Linda gets the grant money to fund her microgravity experiment, she's then going to navigate a complex web of brokers, launch providers, integration providers, and sometimes even NASA, just to get this experiment booked. A year and a half out. It's obvious that the current microgravity landscape is prohibitive to researchers like Linda. This is where we come in. Hudson Space Systems offers a full-stack experience for microgravity researchers. We are the launch provider, the integration partner, and the payload designer, which means we are the only company you need in order to get your payload integrated and straight into space. As a result, we can offer our customers a more cost-effective solution to accessing microgravity. Oh, and that crazy timeline? We're working on that too. We're planning to offer launches every month, which means Linda's going to get her experiments launched easier and faster than ever before. Just imagine the scientific progress that's possible when researchers and startups can access crucial tools like microgravity. Invest in a new space. Hudson Space Systems.